Greetings and welcome to lecture 4.5, Fractions and Decimals. I know I'm going to discuss a topic that you don't really like to discuss, which are fractions. And I don't know anybody that loves fractions except us math people. So let's talk about fractions in relation to decimals, because maybe sometimes decimals are easier to work with. So if we can convert a fraction over to decimal and then follow all of our rules in the decimal world, then that might be easier. So if we recall, our notation for fraction just implies division. So 3/5 implies 3 divided by 5. So if we want to convert a decimal, we're just going to take the denominator and divide it into our numerator. 3/4, let's convert it to decimal. Well, 3/4 is the same thing as 3 divided by 4. So it's going to be 4 is our divisor and 3 is our dividend. So when we take that, 4 will divide into 3 0 times. But remember, our decimal, we bring it straight up. Decimal's right there, we bring it straight up. Now, 4 goes into 30 7 times. 7 times 4 is 28. 30 minus 28 is 2. Bring down the 0. 4 goes into 25 times. 5 times 40. 5 times 4 is 20. 20 minus 20 is 0, and we can stop. So the conversion of 3/4 is going to be the same thing in decimal format as 0.75. Previous example, the decimal came out very nice as 0.75, but sometimes our decimal is going to keep going on and on and on, and so we really need to stop somewhere. We don't want to keep doing this problem all our lives. So let's try a problem that might do that, or will do that. 7/12, and we want to convert it to decimal. Well, 7/12 is the same thing as 7 divided by 12, so that's 12 divided into 7. The denominator divided into the numerator. You're going to do your long division as normal, and you might be able to see, just change pins here. At this point, I get a 40. Do the subtraction. 3 times 12 is 36. I get another 4. Bring down the 0. I get a 40. You'll start seeing this 40 repeat, repeat, repeat. Again, I get a 4. If I brought down a 0, I get 40. So I know this 3 will repeat. So let's round it to the nearest thousandth. So the thousandths position is going to be, there's tenths, hundredths, thousandths. So I need to look at the 10,000th position. If the 10,000th position is 5 or more, 5 or greater, then we're going to round the 1,000th position up. If it's less than 5, then I just truncate. I chop it off. And 3 is less than 5. Therefore, my rounded to the nearest thousandths is going to be 0.583. So 583 thousandths. But for an exact answer where the 3 repeats, we can actually write a line over the 3, and this line signifies that the 3 will repeat. If an 8, 3, 8, 3, 8, 3, 8, 3 repeated, then we draw the line over the 8 and the 3. Let's try a problem. Again, I'm going to apologize. If you watched the last video, you will know that my Surface Pen has died. It's run out of battery, and it takes a very special battery, and I have it on order, and therefore I'm waiting for it to come in the mail. And so I'm writing with my mouse, so apologies all around. My writing's not that great with my mouse. It's much, much better with my Surface Pen. All right, let's convert 3/11ths to a decimal. So it's going to be 11 divided into 3. I'm going to move my decimal place right on up. 11 goes into 3 0 times. 11 goes into 30 twice. That's 22. 30 minus 22 is 8. Bring down the 0. 11 goes into 80 7 times. 7 times 11, pardon me, is 77. Subtract. It's going to be a 3. Bring down the 0. 11 goes into 30 2 times. That's 22. Starting to see a pattern come up here. 8, bring down the 0, I have an 80 again. 11 goes into 80 7 times, and that's 77. Subtract, I get a 3, bring down the 0, and you see that it's going from 80 to 30, 80 to 30, 80 to 30, so I'm going to get this repeating. I mean, it's not going to stop. 11 times 7 is 77. 80 minus 77 is 3. It's always going to be this repeating pattern. So I know my repeating pattern will be 27, 27, 27. So my answer is going to be 0.27. And then above the 2 and the 7, it's a bar. That is the exact answer. This tells me that 27, 27, 27, 27, it repeats. Now to me, converting a decimal to a fraction is a lot, I'd say easier, simpler. At least the starting is really super simple. And then from there it's just reducing. So convert 0.38 to a fraction. Well, this is 38 hundredths. And therefore, that's going to be 38 over 100. And now I just need to reduce my fraction. So 2 goes into 150 times. 2 goes into 38 19 times. 19 is prime, so I can stop. My answer is 19 over 50. Again, if I want to convert 0.75 to a fraction, this is 75 thousandths. Or how you can think about it, that is 3 decimal places after the decimal. I have 1, 2, 3. So my number on the bottom must have 3 zeros. So if you don't remember any of the names of the decimals, that's okay. If you don't know, I mean, it's not okay. You should know that. Let me just put that out there in the world. You should know that. But if you just don't remember, because we say 0.75, 0.378, we don't necessarily say the whole big number. Just like with the whole numbers, we might say 572 for 572. But if you don't remember the name of the actual number, which this is 75 thousandths, then what you do is after the decimal, you count how many digits you have. 1, 2, 3. Therefore, the number on the bottom has that many zeros. From there, I just need to reduce. Well, 75 is 5 times 15, and 1,000 is 5 times 200, so I know the 5 over 5 will be a 1. But now I have 15 over 200. 15 is just 5 times 3. 20 is 5 times 4. Again, I can reduce by 5. And it looks like my answer is 3 over 40. Because 3 is a prime number, I can't break that down anymore. Perhaps I want to write 15.6 as a mixed number. Well, 15.6, that's 6 tenths. So 6 tenths, literally, 6 over 10. And then I'm going to reduce the fraction component. And that will be 15 and 3/5, because 2 goes into 6 3 times, 2 goes into 5 5 times, 3 and 5 are both prime numbers. We can stop. When problems contain both fractions and decimals, you got to choose which one you're going to use. In essence, you can simplify it as much as you can by trying to put all the decimals together, try and put all the fractions together. But ultimately, you're going to have to convert one to the other to be able to get the actual solution. In this example, simplify 19/50ths times 1.32 plus 1.48. The decimal I can combine. Those are in parentheses. I can do that first, and I can combine 1.32 with 0.48. And I probably should say the correct words for those. 1.32 hundredths plus 48 hundredths. 1 and 32 hundredths. Therefore, my decimal is going to be 1.8. 1 and 8 tenths. But I can either at this point change my 1 and 8 tenths over to a fraction, a mixed number, and then into an improper fraction to deal with the fraction that's out to the multiply. Or I can change the 19/50ths to a decimal and And by doing that, then everybody's in decimal. So if I change the 19/50ths into a decimal, there's two ways I can do it. One is I can multiply both of these numbers by 2. That will make the 50 100. And then I can just say, oh, that's 38 over 100, and that's 0.38 in decimal form. If you can't do that in your head, just do the long division. 50 divided into 19. Put the decimal, work that through, that's 0.38. Now everybody's in decimal format. 0.38 times 1.32 plus 0.48. 1.32 plus 48. 0.48 is 1.8. 38 times 1.8 is going to be, scroll down, 0.684. So you do the multiplication, you had 3 decimal places to the right, so from your answer you do 1, 2, 3. I actually used the 0, so it's actually a 4. Right? That's 1, 2, 3, 4. Therefore, my solution is 0.684. Ultimately, when you see these mixed problems where you have decimals and fractions, you can choose to whether to change everything to decimals or everything to fractions. Maybe one way is a little bit easier for you than the other way. So I've used an example of 1/2 plus 0.75 times 2/5, and I've done it both ways, converting to decimals and then converting to fractions. So I'm going to start with converting to decimals. 1/2 is going to be 0.5. 2/5 is going to be 0.4. And if you need to see the math, that's going to be 2 divided into 1.0. 5 times 2 is 10. 10 minus 10 is 0. And again, 5 divided into 2, put your decimal place and a 0. Decimal place up in the quotient. Do your division. 5 times 4 is 20. 20 minus 20 is 0. I can stop. I rewrite the problem using all decimals. 0.5 plus 0.75 times 0.4. Using order of operation, I have to do my multiplication first. So 75 and 0.4, do my multiplication. There are 3 positions to the right of the decimal. Once I do my multiplication, 4 times 75 is 300, but I have to move my decimal over 3 positions. 1, 2, 3. So my answer for 0.75 times 4 is 75.04. I cannot talk today, I guess. 0.75 times 0.4 equals 0.3. My problem now becomes 0.5 plus 0.3. Therefore, my solution is 0.8. Now, if I first decide to change everything to fractions, I have to say 0.75 is my only decimal I need to convert to fractions. That is 75 100ths. I can reduce this. The top number is 75 is 25 times 3. My denominator is 25 times 4. I can reduce by 25, both the numerator and the denominator, so I'm left with 3/4. Now, if you just know that 0.75 is 3/4, you can jump to that solution, but if you don't, just say, oh, 75, that's 75 100ths, so 75 over 100, and reduce as much as you can, you get down to 3/4. Writing 3/4 where the 0.75 was, so I have 1/2 plus 3/4 times 2/5. Well, 3/4 times 2/5, that's going to be 3 times 2 is 6, 4 times 5 is 10, and I can reduce the 6/20ths to 3/10. My problem becomes 1/2 plus 3/10. I have to find common denominator for my fraction. My least common denominator is going to be 10. So I only need to manipulate the 1/2 to have it as the denominator of 10. If I multiply both numerator and denominator by 5. It becomes 5/10 plus 3/10. That becomes 8/10. But remember, I'm in fractions, so I want to reduce that to my lowest term. 8 is 4 times 2, 5 is 5 times, or 10 is 5 times 2, reduced by 2 for each, so my answer is 4/5. Now if you convert 4/5, you will get 0.8. And you may have been able to see it when 8/10, that's 8/10, 4/5 is 8/10. Now maybe you don't need to change over to decimal or convert to fraction in the very start. Maybe you want to simplify your problem as much as you can in the form that they're in, and then when you get to the point where you have to start combining, either multiplying, dividing, adding or subtracting fractions with decimals, that's when you convert them. I have 1/2 cubed times 2.4 plus 1/4 squared times 3.2. I can work with my fraction and its exponent first. I don't have to convert it first. I can work with 1/2 cubed. 1/2 cubed is going to be 1/2 times 1/2 times 1/2. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. So 1/2 cubed equals 1/8. 1/4 squared, that's 1/4 times 1/4. Do the numerators. 1 times 1 is 1. 4 times 4 is 16. So 1/4 squared is going to be 1/16. Now I can look at my problem and see if I need to convert anything. Well, if I have 1/8 times 2.4, that's really 2.4 over 1. And at this point, I'm not going to convert anything. I'm going to do that multiplication. I can do 1 times 2.4, that's 2.4. And 8 times 1 is 8. Likewise, 1 times 3.2 is 3.2. And 16 times 1 is 16. Now, I just need to do the division. 8 divided into 2.4 and 16 divided into 0.32. 8 goes into 0.42 0.3 times. 16 goes into 3.2 0.2 times. And now everybody's in decimals. You would think I didn't convert anything, but I did. Right here in the division, that's really converting this whole number. I'm doing the math. 0.3 times 0.3 plus 0.2 is 0.5. Now I could have changed everybody to decimal, and then I would still get the same answer. So 1/2 is 0.5. 0.5 times 0.5 times 0.5 is going to be 0.125. And 1/4 is going to be 0.25 as a decimal. And 0.25 times 25, let's see, 25, that's going to be 5, carry the 2 is 12, 0, and it's a 5, that's 6, so it's 0.625, 0.625, and then I can go through and I can do the multiplication. I'll still get the same answer. So whether you choose to change your fractions over to decimals or change your decimals over to fraction is ultimately going to be you. But you may want to stick with the problem you have to see if you actually have to do that. In this case, I didn't do any full-on conversions. I just did some divisions within the problem, and it worked out just fine. So when would you use something like fractions and decimals together? Well, I don't know what's wrong with me. Oh, haven't had any coffee today. Anytime that you go shopping and you see a sale for 1/2 off or 1/3 off, that means 1/3 off the price. And therefore, your price is probably going to be in decimals, maybe $19.75 or $20.95 or $25.99 or $25.97 or whatever it may be, it's probably going to be in decimal. I don't know many items that I go to the store and it's just $31. There's usually change involved for whatever reason. Because of that, if I want to know, let's say there's a sale going on and a pair of pants normally sells for $31.95 and it's on sale for a third off, then what's the sale price? Well, that's multiplication, so it's 1/3 times 31.95, and we can think of this as 35.95 over 1, and that's a multiplication now of two fractions. So 1 times 31.95 is 31.95. 3 times 1 is 3. Now we do our division. Remember, a fraction bar implies division. And if we run through that, 3 goes into 31.95, 10.65 times. This 10.65 is your 1/3 off. That's your discount. That is not the price of the pants. That's your discount. So if the discount is $10.65, what's the sale price of the pants? Take the original price. That's your original price is $31.95. And subtract your discount. Oh, that is the most horrible original that I think I could have written. So let's get rid of it. There we go. So this is your original price. And minus your discount, you're going to get $21.30. So the sale price of the pants is $21.30. So that's it for this video. Until next time, again, thank you for dealing with my writing issues. I'll be happy when it's resolved. But until next time, be seeing you.